Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue with our works on polynomials and monomials and how we work with exponents. And today, specifically, we're talking about multiplying monomials, guys. And we're going to talk about the product and the power rules. And the product rule for exponents is very simple. If a is a real number and m and n are natural numbers, then a to the m power times a to the n power is a to the m plus n, period. What the heck does that mean in English? That means that when the bases are the same, you keep the same base and add the exponents. You add the exponents. And you know what? This is wrong. If a is a real number and m and n are actually real numbers as well, because I can have negative exponents. They're not really monomials at that point or polynomials, but I can still have them and I can add them. So what's happening here is, again, if I have the same base, I keep the base and add the exponents. It's literally that easy. For example, 2 to the third power times 2 squared. A lot of times people will say, oh, let's multiply 2 times 2. No. This is 2 cubed times 2 squared. So you keep the base of 2 and you add the exponents literally. So it's 2 to the 5th. Now, if I want you to expand that, that's 2 to the 5th power. Please remember, that's not 2 times 5, guys. That's 2 times 2 times 2 times 2 times 2. Okay? That's the base 2 multiplied times itself 5 times. So that would be 32. X to the 4th times y to the 8th is simply x to the 4th times y to the 8th. Why didn't I do anything? Because the bases are not the same. If the bases are not the same, I cannot combine the exponents, my brothers. M to the 3rd times m to the 5th times m to the 1st. Okay? This is going to be m to the 9th. Very good. Remember that when you just have an m by itself or an n or any variable, please remember that there is an invisible exponent of 1 there. So that would be m to the 9th. You keep the same base and you add the exponents. Negative 3 squared times negative 3 to the 3rd. You keep the base, negative 3, notice it's in parentheses, and you raise it to the 5th power in this case, because you keep the base and add the exponents literally. X to the 8th times x to the 4th, you keep the base of x and add the exponents, x to the 12th. A to the 4th, b to the 5th, c to the 3rd, times a squared, b to the 4th, c. Well, in this case, you go variable by variable. Go ahead, my man, you had your hand up. Try it. Good, brother. A to the 6th. B to the 9th. You got this. C to the 4th. Perfect, my brother. Fantastic. So when you're multiplying monomials, okay, you're multiplying the same variables, you keep the base and add the exponents. Does that make sense, gentlemen? Fantabulous. Good, good, good. Okay, next. The power rule. If a is a real number and m and n, again, are real numbers, not natural. Natural numbers are only numbers, whole values that are greater than 1, and they could be real. So if a is a real number and m and n are real numbers, when I have an exponent raised to another exponent or to another power, I keep the base and multiply the exponents. So I have a to the m raised to the n. It's going to be a to the m times n. If within the parentheses I have a times b raised to the n power, okay, I'm going to literally, there's an invisible exponent of 1 here on the a and an invisible exponent of 1 here on the b. I'm going to literally distribute the n to the 1 and to this one. So therefore I have a to the n times b to the n. So I will distribute that outside exponent to all of the exponents inside of that parentheses. It's literally that easy. Yes, sir, my brother. You're, because you're multiplying, you're distributing. You're taking this outside variable and exponent, and you're multiplying it to all the exponents inside.
So why don't you have like just a m n? Why is it a m times n?
Mn and m times n are the same thing. Mn is the same thing as m times n. I just put the dot there to, really show you clearly that it's being multiplied. Thank you for asking. Thank you for caring. So in this particular case, guys, I have 2 to the third power raised to the second squared. So this is 2 to the sixth power. Done. Okay. Y to the 20th. Because I take this 5 and I distribute it to all the exponents. 4 times 5 is 20. Now here, what would this one be? X to the third, y to the sixth. Beautiful, gentlemen. There's an invisible exponent of 1 there. So 3 times 1 is 3. 3 times 2 is 6. Fantastic. Well done. Excellent. Here. Looks complicated, but it's not. This bracket here. It's just a fancy parentheses. I take that exponent, I distribute it. So this would be negative 3 to the sixth power. Okay? Please remember, this would be negative 3 times 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 negative 3. That's what that would equal, okay, if I wanted you to expand it. And also, please remember that when a negative value is raised to an even power, the answer will always be positive. When a negative value is raised to an odd power, it will always be negative or stay negative. Okay? When I have large exponents like this, I probably will not make you evaluate, even though this one's pretty easy. When I have reasonable ones, like example E, I will make you evaluate it. So this is negative 5 to the third. Make sure that when it's in parentheses like this, you keep it in parentheses. This is negative 5 to the third and to the 15th. Very good. Negative 5 to the third. Negative 5 times negative 5 is 25. Times the third negative 5 would be negative 125 n to the 15th. Did everyone see where that negative 125 came from, my brothers? Thank you. How about negative 6 x cubed y squared raised to the third power? What would that be? Make sure you put that negative 6 in parentheses, gentlemen. If you don't put it in parentheses, then you're not including that negative, and you will get it wrong, unfortunately. So negative 6 to the third power, x to the ninth, y to the sixth. So negative 6 times negative 6 is 36. And then 36 times negative 6 is negative 216. Thank you so much, guys. X to the ninth, y to the sixth. Not too bad, right? Pretty simple. Awesome. Okay. Now we're going to put it all together. We good? May I continue? All right. Let's do it. Let's put it all together, guys. Let's multiply and simplify each. Okay. And yeah, and then we're done. Okay. So in this particular case, let's see what I got here. Go numbers with numbers first, then variables with variables second. What would I get there, my brother? No, go ahead, my man. Yeah, 30. X. No. Why would you be multiplying? You're multiplying the same base, so you're adding the exponents, so it'd be 30x to the sixth. When you multiply the same base, you add the exponents. When you raise a power to a power, you multiply the exponents. Thank you for caring, and thank you for trying. How about for B, my brothers? What would this be? It would be negative 10. Very good. P to the fifth. Very good. Next. Okay, it's not negative 6, first of all, because we have an exponent here first. Remember the order of operations. Order of operations, PEMDAS, please excuse my dear Aunt Sally, you're going to have to do the exponents first, guys, before you multiply. So you're first going to distribute this power of 2 to every single one of these, right? So what would that give you first? That'd give you 9 because negative 3 squared is 9. X to the 4th, y to the 6th, excellent, times, no, 2 to the 4th is not 8. 2 times 2 is 4, times 2 is 8, times 2 is 16, x to the 12th, because 4 times 3 is 12, not 7. When you raise a power to a power, you multiply. And then y to the 4th. Very good, gentlemen. Now, let's go ahead and multiply. 9 times 6 would be, 9 times 16 would be
144.
144. Excellent. X to the 6th times x to the 4th times x to the 12th would be x to the 16th. Y to the 6th times y to the 4th would be y to the 10th. And bingo. We're golden. I did add the exponents. I did multiply them though, guys. I did. Y to the 6th times y to the 4th is y to the 10th. When I multiply the same base, I add the exponents. When I raise a power to a power, I multiply the exponents. When I multiply the same base, I keep the base, add the exponents. When I raise a power to a power, I keep the base and multiply the exponents. Okay? We got time. Let's do some more practice. Yeah? Let's try some more. Okay? I'll just create some by hand real quick. All right? Let's do another example. Let's do, how about this one? Let's do 2x cubed y squared cubed times x to the 4th y squared. Simple. Okay. What do we got here first? Let's first do with our exponents, gentlemen. What would we get here? Okay, we got to distribute this 3, right? We got to distribute this to all the exponents, right? So 2 to the 3rd power would be 8, x to the 9th, y to the 6th, beautiful, times x to the 8th, y squared, excellent, which would equal 8, x to the 17th, y to the 8th. Fantastic. Good job, gentlemen. Good job, gentlemen. How about this bad boy? X y cubed z cubed times x squared y to the 4th z to the 4th. Okay. What would I get here, gentlemen? X to the 3rd. Okay, you keep going, my brother. Y to the 9th. Z to the 3rd. X to the 8th. Y to the 16th. Z to the 4th. X to the 11th. You got it. Y to the 25th. And Z to the 7th. Fantastic. Does that make sense, my brothers? Yes, sir.
What if instead of, like, say the base were already not like that, like x, y, z?
Yes, sir.
It was y, x.
It doesn't matter the order. Let me explain what that means for people watching that didn't understand that question. What my boy asked was this. Let's say I have x squared y to the fourth z cubed squared, but then over here I have y to the fifth x squared y cubed squared as well. The question was, oh, but the order is different. It doesn't matter because of what property? The commutative property of multiplication. You can change the order of multiplication without changing the answer. So thank you. It's a wonderful question. But now, let's go ahead and follow it up. What would that be, my man? Tell me. No, it would not be 4x. It'd be x to the fourth. Good job. Good man. Y to the eighth. Z to the sixth times z to the 10th, x to the fourth, y to the sixth. Now let's wrap it up. You don't have to go by order. Just make sure you go by the proper variable, all right? So what would that be, my man? X to the eighth. Very good, because you went this guy and this guy. Good. Y to the 14th, because y with the y. Excellent. And then z to the 16th. This guy and this guy. Fantastic. Super. Does that make sense? Any questions, my brothers? Excellent job, guys. You have a question? Yes, sir.
That would be a 60 degree.
No, this would not be a 60th degree. Actually, this would be a 38th degree monomial. Because to find the degree of a monomial, it's the sum of all the exponents. Thank you for caring, though, and trying. Any other questions, guys? Thank you very much. Hope you learned a lot, and have a wonderful day.